Okay, let's dive straight into this. Welcome to another highly strategic explainer. I am your host, and today we are looking at a topic that consistently trips up even the most prepared computer science students: the applications of interrupts in computer systems. Whether you are tackling IGCSEs like Syllabus 0417, 0478, 0983, 0984, O-Level 2210, or facing the absolute beast that is Cambridge A-Level 9618, you need a flawless strategy. We are going to treat today like a masterclass in exam technique. Think of yourself as a sculptor. You don't just grab a massive lump of rock clay, or, in our case, a giant block of generic textbook facts, throw it at the exam paper, and hope it sticks. You have to carefully chip away the irrelevant fluff to reveal a context-specific masterpiece. To show you what I mean, let's look at a real Cambridge past paper question. Imagine two students facing this paper. Let's call them Alex and Sam. Alex overloads his paper with raw memorized facts about interrupts, but includes absolutely zero analysis. Sam, on the other hand, rushes the question in a panic, completely misses the command word requirements, and writes a totally off-topic paragraph. Both of them leave the exam hall feeling confident, but both of them are about to lose massive marks. We are going to fix that today.
Here is the exact agenda we are going to use to upgrade your exam technique today. First, we will break down the challenge. Second, we look at the procedural framework. Third, critical analysis and evaluation. Fourth, crucial examiner warnings. And finally, we will build your ultimate sculptor's blueprint. Let's get to it.
Section 1. The challenge. We are dealing with the raw block of knowledge, and frankly, we need to talk about why that raw knowledge is actually your biggest enemy in the exam room if you don't know how to wield it. Before we can start sculpting, we really need to address this massive hurdle. Why exactly do students find applying concepts to completely unfamiliar contexts so incredibly hard? Listen, this isn't just a random question I came up with. This is the exact question senior Cambridge examiners are asking in their official reports year after year. The syllabus makes it crystal clear that true mastery isn't just about rote memorization. Let's look back at Alex and Sam. Alex memorized every single definition of an interrupt, but when the exam presented a scenario about a robotic arm on a car assembly line, Alex just wrote down the generic textbook definition. Sam saw the command word evaluate, but just described the process instead, completely ignoring the analytical requirement. Top-performing candidates do not do this. They exhibit a connected, conceptual understanding that transfers seamlessly to unfamiliar scenarios. The challenge isn't knowing what a hardware or software interrupt is. The real challenge is explaining what that specific interrupt is doing right now, in the exact system the exam paper just described to you. Look at this split screen. This brilliantly illustrates the exact difference between an average candidate and a top-performing one. On the left, we have the average approach. This is our student Alex. Alex just lists generic facts. Quote, an interrupt is a signal to the processor, unquote. Quote, it stops the current execution, unquote. Okay, yes, it is completely true, but it is entirely raw and frankly, it is boring. Now look at the right side. This is the sculptor's approach. The master sculptor takes those exact same facts, but molds them directly to the context. If the scenario is about a chemical plant temperature sensor, the master sculptor explains how that specific sensor sends the interrupt, why that specific chemical process needs pausing immediately, and what the interrupt service routine actually does to handle that exact temperature spike. Every single point you make must be actively linked to the scenario on the page, otherwise the examiner is just going to cross it out with red ink.
Moving on to Section 2, the procedural framework. Now that we know what not to do, let's look at the actual tools required for systematic processing. We are going to reveal the strategy that guarantees you hit those command words perfectly.
Complex interrupt problems cannot be solved by just staring at the paper and hoping for inspiration. They require a strict, repeatable method. Whenever you tackle an exam question on interrupts, you must follow this standardized sequence, which pairs perfectly with the famous PEEL framework: point, evidence, explanation, and link. Step 1. Identify the key elements. Extract the relevant data from the scenario. This is your point. Step 2. Apply the relevant principles. Which part of the interrupt cycle applies here? That is your evidence. Step 3. Execute your analysis with clear working. That is your explanation. Step 4. Verify your results. Step 5. Present your answer in the appropriate format, using the correct terminology. This creates a solid link back to the question. So I have a quick challenge for you. Look at the two answers on your screen. You have a 30-second timer starting in your head right now. Spot which answer actually follows the PEEL framework. Is it the one that just lists facts, or the one that states a point, backs it up with scenario evidence, explains the CPU process, and links it back to the chemical plant. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, let's talk about the absolute goldmine of computer science exams, the method mark strategy. This is the secret to how top students structure their answers. The crucial point here is that examiners award marks for the explicit analytical process you show on the paper, not just for having the correct final conclusion. When you are sitting there interpreting binary representations of an interrupt register, or you are tasked with designing an algorithm to handle different priority levels, the examiners desperately want to see you're working. They are testing your data interpretation. They are testing your programming logic. If you jump straight to the final answer without showing the procedural framework, you are literally leaving easy marks on the table. Show the logic. Show the steps. Prove to the examiner that you didn't just guess.
All right, Section 3, Critical Analysis and Evaluation. We are moving from basic application into achieving true analytical depth. This is where we transform those red pen marks into green check marks.
The Cambridge Assessment Framework heavily prioritizes analytical depth over superficial breadth. When you are evaluating the quality of an algorithm for handling interrupts, examiners are looking for a highly specific breakdown. You absolutely must identify these 3 metrics. First, time complexity. Think about it. How long does it actually take the interrupt handler to execute? If it's too slow, the system crashes. Second, space complexity. How much memory is required to safely push the current state of the CPU onto the stack? And third, edge cases. What happens if 2 critical hardware interrupts arrive at the exact same millisecond? Right now, imagine a 60-second timer on the screen. If you were rewriting Sam's rushed answer from earlier, you would need to inject these metrics. Don't just list them, though. You must explicitly state their effect on system performance. If the stack memory overflows because of poor space complexity handling, the robotic arm fails. That is the level of depth you need to be aiming for.
Furthermore, higher-order objectives on these papers demand that you evaluate alternatives. Let's look at the Computer Science Success Blueprint. When you are comparing different approaches to handling system events, like comparing a basic polling system versus a dynamic interrupt-driven system, you must identify similarities and differences. Use comparative connectives in your writing. Use words like whereas, however, and conversely. And most importantly, support absolutely every single comparison with evidence from the given scenario. Draw a firm conclusion about their relative importance. If the scenario is a real-time medical monitor, polling is too slow. Interrupts are life-saving. This is the absolute hallmark of logical, structured reasoning that gets the top grade.
Section 4. Examiner Warnings. This is where we start aggressively chipping away the irrelevant and the incorrect. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get into the warnings.
We are kicking off our interactive workshop right now. I want you to imagine a complex data chart on the screen showing CPU usage during multiple interrupt requests, and you have a 60-second countdown timer to scan it. What are you looking for? You are looking to avoid the top 3 reasons students lose easy marks, pulled directly from the principal examiner reports. Warning number 1, forgetting to check for overflow when interpreting binary flags or performing calculations related to the stack. Warning number 2, missing boundary conditions and edge cases, meaning the student totally forgot to test the absolute limits of their algorithm. And warning number 3, providing answers that are not specific to the context. When you write your next practice answer, double-check your binary math, test the extreme scenarios, and ask yourself objectively, does this paragraph actually fit the specific prompt?
Challenge 2 in our workshop, Find the Flaw. Listen to this direct examiner alert quote. The classic mistake is providing generic answers not specific to the question context. I cannot emphasize this enough. Let's look at a flawed sample sentence from our student Alex. Alex wrote, "The processor stops its current task and handles the interrupt using the ISR. Your job is to find the flaw. Why does that lose a mark? Got it? Because it is totally generic. It doesn't say what task the processor stops, and it doesn't say what the ISR is handling in the context of the exam scenario. You might write a beautifully accurate description of a hardware interrupt, but if the question asked about a printer running out of paper and you never once mentioned the printer, you are going to tank your score. Always link every point to the given scenario."
Section 5, the sculptor's blueprint. We are finally bringing it all together to craft the final masterpiece. Get ready for our final interactive speed challenge.
Let's combine our theoretical architecture with practical exam strategy. Here is challenge 3, speed writing. Imagine a 30-second timer counting down. To write a perfect Peel paragraph that fast, you need a powerful memory hack. Don't memorize boring bullet points. Instead, encode the intricate processes of computer interrupts as a highly visual unfolding story in your mind. Visualize the CPU happily running its main program. Suddenly, it receives an urgent flag. It halts its work. It pushes its current state safely into a stack in the memory, almost like carefully placing important books into a heavy box. Then it runs off to deal with the emergency in the interrupt service routine. Once that's solved, it comes back, unpacks the box from the stack, and seamlessly resumes its original task. Visualizing this sequence of events as a story makes it vastly easier to adapt the concept to whatever crazy scenario the exam throws at you in record time.
And here is your ultimate complete answering system, containing the 3 rules that guarantee top marks. First, rely on precise definitions and command word decoding. If it says evaluate, you must give pros and cons. Second, establish clear causal relationships using the Peel framework. If X happens, then Y is triggered. Explain the why. And third, use a time management matrix to ensure you highlight cross-topic connections without running out of the clock. The principal examiner reports specifically highlight the candidates who reference cross-topic connections, for example, linking a software interrupt process back to underlying data representation or logic gates, achieve significantly higher marks because it demonstrates a deeply holistic, structured understanding of computer science.
So I leave you with this final provocative thought. How will you apply this sculptor's procedural framework to decode your next past paper? The raw clay is your textbook knowledge, but the masterpiece? That is your ability to use the method marks, the critical analysis, and the context-specific application to carve out a perfect answer. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep building those analytical skills, and I'll see you next time.